Bonjour. I would like to thank the organizer of the symposium for the invitation to present the third installment of the GEM program recently approved. GEM was a 12-year, 200 million geological mapping program delivered by Natural Resources Canada's Geological Survey of Canada, GSC. At the time, Canada still had an insufficient understanding of the geology of vast tracts within its northern territory. Old data and old models often make for outdated conclusions. In collaboration with provinces, territories, and indigenous communities, the program included an extensive series of research projects which explored the structure and evolution of Canada's northern geology, including mineral and energy resources potential of the region. These studies, led by American scientists, included experts from leading Canadian and international research institutions, both in conducting field and subsequent laboratory analysis, data integration, and interpretation. GEM focused on characterizing the regional geological context, thereby providing frameworks to establish whether geological formation have a high or low likelihood of resource potential. The new program will continue to enhance our geological understanding of Canada's north, focusing on areas with high potential for minerals and other mined communities, as well as where development is likely to occur and benefit northern communities. GEM GeoNorth will also conduct complementary geoscience research, such as the study of permafrost in the northern environment, to increase our understanding of rapidly changing Arctic and northern landscapes and coasts, and how to address these changes. This complementary geoscience is relevant to assess risk to northern infrastructure. GEM benefited from an active advisory group of Northerners representing the diversity of the northern context. Membership is drawn from indigenous socioeconomic development organizations and governance organizations, the private sectors, and territorial governments. The group provided key advice on building respectful and sustainable relationship with indigenous and northern peoples, communities, and organizations, as well as maximizing the uptake of GEM knowledge by Northerners. In the past, the AGN focused on developing four main themes: community engagement and stakeholder relationships, capacity building and skills development, integration of knowledge and data for decision making, messaging and communication with Northerners. For the new program, one of their first mandate will be to advise us on how we can co-develop research priorities with Indigenous governance organizations. GEM GeoNorth can count on 5 strong pillars: the ability to refine geological knowledge, the ability to enhance understanding of rapidly changing landscape and coast to support economic development via critical infrastructure, to develop and provide new public geoscience to inform environmental assessments, to leverage innovative data-driven predictive methods to forecast cumulative impacts in a changing climate, and most important, co-develop research priorities and products with Northerners and Indigenous peoples. However, GEM GeoNorth is not a new kid of the block. It will build on foundational geoscience from the first 2 phases of GEM and will develop new knowledge and tools useful to industry, governments, and northern communities, supporting mineral resource development and sustainable land use in the context of a changing climate. The impacts of GEM research can be felt across many fields and sectors, including resource exploration, environmental studies, infrastructure, land use decision, geoscience training opportunities and capacity building, improved research methods and models, technological and infrastructure development, and in unexpected scientific discovery. More than 2,000 maps and reports have increased publicly available geoscience information about Canada's north, including the identification of areas of high potential for critical minerals such as gold, nickel, platinum group elements, rare metals, base metals, and diamonds. Let's investigate some of these successes. Now I would like to introduce some of the GEM successes in the Northwest Territories. One is related to the smoking hills in northwest part of the Northwest Territories. Fieldwork helped characterize the volcano for which the area is named. Slumping bedrock leads to spontaneous combustion of pyrite-rich bedrock at numerous sites along the cliff of Franken Bay and inland along the Horton and Anderson rivers. The smoke is a combination of water vapor and sulfuric acid gas. Fieldwork also led to the discovery of the Smoking Hills Formation bedrock as a source of natural acid rock drainage. Streams and ponds in contact with it develop hyperacidic waters, some with a pH as low as minus 1.44, stronger than sulfuric acid. These waters also contain toxic concentration of many dissolved metals, including cadmium, at 7,000 times the recommended Canada Safe Drinking Water guidelines. In the Great Bear region, in July 2019, Fortune Minerals announced the discovery of a new copper mineralization potential at their gold, cobalt, bismuth, copper, nickel project, building on GEM1 collaborations and data from the Great Bear region project. Renewed exploration at Nikos stems from Fortune Minerals' new finding and from GEM and the Targeted Geoscience Initiative (TGI) research results. Instrumental to all that is GEM geological and geophysical data and the program's collaboration with Fortune Minerals, which supplied researchers with large amount of geophysical data for modeling, as well as free accommodation at their camp for 3 summers for regional fieldwork. Also, the work we did in GEM Great Bear is key to assess the natural metal content of rocks, both in till cover and in rocks, through the Great Bear Magnetic Zone, and information also important for our environmental watershed studies. GEM conducted permafrost studies, superficial mapping in the Great Slave region, and glacial sediment mapping in thaw-sensitive terrain identified extremely useful information for land use planning, infrastructure, and resource development. The Northwest Territory Department of Transport used GEM sufficient geological data to help plan the route of the Clico All-Season Road, an estimated $400 million project. The road project, which avoids the thaw-sensitive terrain that affects the highway from Yellowknife to Big Koklo, is now 70% completed and is planned to provide community access by the fall of 2021. The All-Season Road will also link the gold, cobalt, bismuth, copper, nickel project to the rest of the world and increase the feasibility of opening a significant critical metal mine in Canada. For the Nunavut part of the symposium, I would like to introduce the work that we did along the Northwest Passage. GEM discovered unique differences in bedrock underlying Boothia Peninsula and Somerset Island, indicating that mineral exploration strategies used in other areas are likely inappropriate for the Northwest Passage. GEM research provided relevant data and knowledge for this isolated region of Nunavut regarding resource assessment and economic development opportunities associated with potentially dramatic increase in shipping due to climate change impact. South of that area, in the Ray province, fieldwork in the Chantry-Talon area identified 3 main areas with economic potential in 3 different geological domains: newly recognized copper, nickel, platinum group elements, and massive sulfide resource potential. High-resolution satellite imagery, integrated with information from over 14,000 field stations, was used to produce new maps of glacial landscape and surface materials west of Hudson Bay, synthesizing comprehensive historical and new GEM dataset in a critical area with known economic potential and planned transportation corridors between northern communities. Regarding land use planning, I would like to present a case in the Yukusikasalik National Park. GEM knowledge on uranium potential in the Kivalik region was taken into account when expanding a protected area. The national park in Nunavut was expanded by 327 square kilometers in 2014 after an exchange of land between the Government of Canada and the Kivalliq Inuit Association that was informed by results from the GEM program. GEM funded the Satu Geomapping Initiative for the acquisition and integration of several new GIS datasets into a cohesive atlas. For example, GEM research projects, archaeological data, community knowledge, resource interest, and exploration activities. Emphasis was on training users to technically navigate the atlas so that they can explore the information related to their unique needs and at their own pace. Within the GEM Engagement Initiative, GEM held a geoscience field school in the community of Toliak, Nunavut in 2016. More than 160 community members of all ages took part in the field school, which took place over 5 days. The field school presented a unique opportunity for residents to learn more about the geological feature of their land, and it connected geoscience to local and traditional knowledge. Beside those successes, there were several unexpected discoveries during those 12 years of GEM. A routine sample collection led to a unique discovery in the evolution of life on Earth. Microfossils of fungi were revealed in samples of shale roughly 1 billion years old from the Western Canadian Arctic, pushing back the earliest known occurrence of fungi on Earth by more than 500 million years. Just for your information, the fossil was about half of the width of a human hair. This discovery helps refine the evolutionary tree of complex organisms in the history of life on Earth. The story, published in the journal Nature, was picked up by major newspapers around the world, including the New York Times and The Guardian. Another unexpected discovery was, while analyzing samples from sedimentary rocks in the Ray region in Nunavut, researchers from the GSC made a rare discovery: presence of a 7-centimeter thick bed of impact spherules, an indication of a large meteorite strike somewhere on Earth about 2.1 billion years ago. 4 new stratigraphic sections depicting how rock layers are deposited, including succession and age, were measured on Bylot Island, Northern Baffin Island. Common stratigraphic succession allow identification of regional and local nonconformities and help sequence stratigraphic framework of the offshore succession. Another aspect of the research was quite exciting when finding possible theropod dinosaur tracks. These were found in rocks that accumulated in the shallow marine lagoon along the coast of ancient Baffin Island about 100 million years ago. If dinosaur tracks were made in these rocks, that means that the dinosaur must have lived nearby. This is likely the world's most northerly dinosaur tracks. The high latitude location of the region at that time tell us that the dinosaurs and other lives that lived there must have experienced long periods of darkness during the winter. Imagine what it must be like for a dinosaur to be in the dark for 6 months in a year. A very exciting find of the research program was an ancient marine reptile, which was found in sedimentary rocks in the north side of Bylot Island. Pieces of bones from the paddles or the flippers of the marine reptile were brought back to the lab for identification and were determined to be from a plesiosaur. Plesiosaurs went extinct about 65 million years ago. So we know that the rocks on which the plesiosaurs were found have to be at least that old. Again, the ancient creature from Bylot Island is the most northern example of a Cretaceous plesiosaur. GEM GeoNorth will develop new knowledge and tools useful to industry, governments, and northern communities, supporting mineral resource development and sustainable land use in the context of a changing climate. GEM GeoNorth approach strengthening the role of Northerners and Indigenous peoples in co-developing research priorities, knowledge products, and capacity building opportunities will potentially increase the program effectiveness in addressing local concerns in earlier stage of program delivery compared to previous phases of GEM. The upcoming next steps for GEM GeoNorth include finalizing the co-development of research priorities between GEM GeoNorth, territorial and provincial geological surveys, the AGN, Indigenous and Northern organizations and industry associations. Discussions are underway with territories and provinces and shortly with Indigenous groups to define research priorities of the renewed program. Call from academic grant proposal and for grant proposal from Indigenous communities and organizations will start next fiscal year. Contingent to public health measures, first NRCan fieldwork within the GMGO North program are targeted for summer 2021. NRCan would engage with Northern and Indigenous communities before any fieldwork can proceed, consistent with the best practices from the first 12 years of GEM. Thank you to have listened to me, and if you have any questions, I will be pleased to answer them.